Greetings, ACT specialist. Now we're going to take a look at how many liters does this balloon take up if I know that there are 0.50 grams of Cl2 inside. So of course I could measure it, estimate, but if I take the balloon before, blow it up, and take the mass afterwards, both before and after, I can measure the grams and be sure of the exact volume because the balloon is oddly shaped, right? So even if I estimate with a sphere, it's not a perfect example. So let's take a look at this one. And okay, so let me actually play this. All right, there we go. Okay, so I've got 0.50 grams of Cl2 inside. That's what I know, and I want to know how many liters it takes up, right? Okay. So let's think about this. Well, I'm going to move this down a little bit so I have a little bit more space. All right. I know I'm going to write a plan. All right, I know I'm starting where? Let me use a different color. Let's start with red. I know I'm at grams, okay? So I know I'm right here. And I know I need to get to liters. Now, there's an important thing I need to do here because in order to get to liters, right, this only works for gases, first of all. Okay, Cl2 is a gas, so that's okay. But second of all, I need to assume that we are at STP. So I need to assume we're at standard temperature and pressure. This means that the temperature equals 0 degrees Celsius and the pressure equals 1 atm. So those are both important things. All right. And now that I know that, I know I'm starting with the grams. And I need to get to moles. I could do that in one step using the molar mass in the periodic table. And then from moles, I could jump up to liters. So let's do that. All right. So I got 0.50 grams of Cl2. I know I want to get rid of the grams of Cl2. I'm going to moles of Cl2. I'm thinking, okay, well, how do I convert from grams to moles? Right, I have the periodic table, okay? I just happen to know in 1 mole of Cl2, there are 70.9 grams of Cl2. There are 2 Cl, so 35.45 times 2. All right, and that'll give rid of my grams, and now I'm at moles. So fantastic, that's great. I'm at moles here, but I still got one more step. I've got to get to liters, okay? So I finished my first step. Now let's do step 2. In step 2, I know I need to cancel my moles of Cl2. And I know I'm trying to get to the liters of Cl2. So that's what I'm trying to do. And I'm thinking, okay, well, if I know it's at STP, I know in 1 mole of Cl2 there are 22.4 liters. And so I can do that. I can do this. I take my 0.50, 0.50 times 22.4, and then I'm going to divide by the bottom, 70.9, and that's going to give me 0.1579687 liters of Cl2. But wait, I see I have 2 sig figs here. This actually should be 4 if I kept everything, and then 3. So I know this only has 2 sig figs. That's at least 0.16 liters of Cl2 here. Did I do that right? Yeah, okay. So, that's not very much. So, all right. Well, that balloon probably does not actually take up 0.16. It would actually take up much less space. Well, no, yeah, probably not. That's probably a little too big for 0.16. All right. So, that's great. Okay, I'm going to clear this. And now what I want to think about is, let's say it's not a gas. Let's take the situation where I have this piece of aluminum. And I weigh this piece of aluminum, and this weighs 26.98 grams. Okay, so it's a similar problem. And I want to know how many liters still. Okay, so I'm still trying to figure out how many liters. Well, it's the same plan, right? I'm going to grams to moles to liters. Okay, so what I might do is I might say, okay, I've got 26.98 grams. 8 grams, okay, of aluminum, and I'm going to multiply, and I know the molar mass of aluminum is, it also happens to be 26.98, so 26.98 on the bottom with the grams per 1 mole. Remember, the molar mass tells me how many grams are in 1 mole. Okay, and I know the grams cancel out. I'm at moles, and then I might think, hey, look, in 1 mole of aluminum, there are 22.4 liters of aluminum. And I might calculate that. I say 26.98 divided by 26.981 times 22.4, and I say, hey, that's 22.4 liters of aluminum. Okay, but then I'd be like, wait a second, 22.4 liters of aluminum for this much? And I see, well, this Coke can has 0.355 liters, and this isn't even as big as this, so there's no way that this is going to be 22.4 liters. So I've made a mistake somewhere, right? And the mistake that I've made is that, remember, this only applies for gases. So if it's not a gas, like a solid, this doesn't work. In fact, solids are much more dense and compact than gases, and so take up much less space. Instead, if I actually wanted to do this conversion, all right, which I often do, I need the density. Remember, the density gives me the grams per milliliter, and so that's going to allow me to do this. So let me actually calculate this the proper way, and what I need is the density, okay? And the density for aluminum, if I look on my chart, is 2.6 grams per milliliter. Okay, it's 2.7 grams per milliliter for aluminum. And so what I'm going to do is I'm going to again start with 26.98 grams of aluminum, and I'm going to convert. And I know that's my density, and I know I'm trying to get to, well, liters, I guess, or milliliters. So let's see what happens. I know I can get from mass to volume using the density because I have the mass and I have the volume, so I have the conversion. I'm going to put my 2.7 grams of aluminum on the bottom, and I know I'm converting to 1 milliliter of aluminum. Okay, and if I do that, I take 26.98 divided by 2.7, and that's going to give me 9.99 grams of, sorry, not grams, milliliters of aluminum. But wait, I've only got 2 sig figs here, so I want to keep 9.9. Okay, I want to keep that, but then I have to round, and if I round, I get 10. So I'm thinking, wait a minute, I can only keep 2 sig figs, so what I actually have to keep is 10 milliliters of aluminum, underlining that to show that that's significant. And so what I actually find is that this is about 10 milliliters of aluminum, and that makes more sense because milliliters are kind of small units, and this is 10 milliliters. Okay, so just to wrap up, to think about it, if I want to convert from grams to a volume, I need the density. I can't use that 22.4 liters. That only works for gases. So remember that. You need the density if you want to get the mass of something to the volume. All right, until next time, King out.